Welcome back to Unit 10 and the third video on the playlist for our unit on equilibrium. Since the expression for KEQ is the ratio of products over reactants, if there are fewer products than reactants, KEQ will be less than 1. And of course, if there is less product than reactant, KEQ will be greater than 1. You might be wondering about a situation when products and reactants are about equal and KEQ is close to 1. The concentrations of reactants and products could be equal with a value of KEQ that's not exactly equal to 1 because of differing exponents. But in general, if an equilibrium value is approximately 1, the concentrations of reactants and products are considered to be approximately equal. With that understanding in mind, let's return to our classroom, where our students are about to summarize what they now know about KEQ.
So let's finish up our discussion about equilibrium constants by developing a statement that describes the relationship of the equilibrium constant to the relative amounts of the reactants and the products. So write your statements on a whiteboard, and then we'll share them shortly.
So we need to describe a large KEQ and a small KEQ, and mean in terms of reactants and products.
Well, KEQ is products over reactants. So if there are a lot of products, then KEQ is large, right?
All right, let's see what you came up with. Who would like to share their work?
We will. We just said that if KEQ is large, then there are more products than reactants. And if KEQ is small, there are more reactants than products.
Good. Well, what did you guys come up with?
That's pretty much what we said. We just added values to our statement.
Right, we said that if KEQ is less than 1, reactants are at a higher concentration at equilibrium. If KEQ is greater than 1, products are at a higher concentration at equilibrium. And if KEQ is close to 1, then the concentrations of reactants and products are about equal.
Good job. So let's summarize what we've learned so far about equilibrium. And what I'd like to do is just go around the table and each person mention one thing that they've learned. So Danica, why don't we start with you?
Sure. A reaction has to be reversible to reach equilibrium.
The rate of the forward reaction has to be the exact same as the rate of the reverse reaction to be at equilibrium.
We can find out if a reaction makes more products or more reactants from the equilibrium constant KEQ.
KEQ is a constant as long as the temperature doesn't change.
Very good. Nice summary, everyone. Now I have a question that I like to ask all of my students. And it is, why do you think that equilibrium is even relevant in our everyday lives? And so I'd like you to think about it. Why is equilibrium so important?
Another great question. Why is equilibrium important? I'm betting you already have some ideas in mind. So let's take a break and give you a chance to write down some examples of systems in everyday life that are in chemical equilibrium. Remember our 3 key words. Think of systems that are stable, balanced, or unchanging. When you're ready, and you've come up with 3 everyday examples of chemical equilibrium, go to the next video on the Unit 10 playlist. I'll see you there.